Do humans have the ability to predict the future? No worries. Artificial intelligence can help humans achieve the dream by creating a time series predictions algorithm that can precisely predict a company's monthly sales. Without the ability to predict, especially during the COVID-19 pandemic, where already 2,713 SME companies have been closed down up until October of 2020, and the manufacturing sales experiencing a significant drop of 33% in April 2020. Mr. Harry Dent, a contrarian, who used to predict that there will be a cataclysmic market crash from late 2017 to early 2020, not due to one misfortune. Thus, there are three objectives in my research. Firstly, to select and collect actual company data and pre-process them to facilitate the forecasting process. Second, to identify and formulate ARIMA and LSTM algorithms for predicting the monthly total sales for a company. Lastly, to validate the future 3 months of total sales for a company using ARIMA and LSTM algorithms via simulation. What is ARIMA? It is the combinations of autoregressive AR, integration I, and moving average MA. ARIMA is characterized by the three important elements P, D, Q, where AR represents the element P that depends on the relationship between current observation and the lag observations. I represent the element D that stands for differencing the observations to transform the non-stationary observations to stationary observations at various times. MA represents the element Q that depends on the relationship between observations and the residual error terms when the MA model is applied to the lag observations. What is LSTM? LSTM is a type of RNN where RNN contains internal memory that can function highly effectively in time series prediction. Therefore, in the LSTM structure, due to the internal memory, the prior time's data can be obtained and used the next time. The LSTM can memorize the data for a long period and decide which previous data the structure wants to use. The software required in this computer-based simulation project are Google Colaboratory and Python language. The Pandas library reads the dataset in a .csv file into Google Colaboratory. NumPy library converts the dataset into array format in LSTM. Step Models library implements the augmented Dickey-Fuller ADF test and plots the autocoloration function ACF and partial autocoloration function PACF graph. TensorFlow library calls the Keras function for constructing the LSTM model. Matplotlib library used to display the result in a graph. Lastly, the sklearn library calls the min-max scalar function for data normalization and denormalization. The flowchart on the right-hand side shows the procedures of the ARIMA algorithm. Firstly, the dataset of the company is inserted into the Google Colaboratory. Second, the dataset is pre-processed and displayed in a graph for better visualizing. Third, the stationary test is carried out to determine either the dataset has a constant mean and variance. If the dataset is not stationary, the differential operation is carried out. If the dataset is stationary, proceed to the next step. Fourth, the ACF and PACF graph are generated to determine the P and Q of the ARIMA model. Fifth, the best ARIMA PDQ model is determined. 6. The data set is split into training and testing set with a ratio of 7:3. The table at the left-hand side shows the number of observation months allocated to the training set and testing set. The dataset is taken until April 2021 for every company. 7. The ARIMA PDQ model is ready for monthly sales prediction. 8. The accuracy of the ARIMA model is determined by evaluating the RMSE. Theoretically, the RMSE value should be close to the actual mean. Thus, the equation to calculate the percentage error is as shown. If the RMSE is unsatisfied, return to the fifth step to change the PD and Q parameters. If the RMSE is satisfied, proceed to the next step. 9. The unknown future 3 months monthly sales are predicted using the determined ARIMA model. 10. The graph of predicted monthly sale is displayed. The flowchart on the right-hand side shows the procedure of the LSTM algorithm. Firstly, the dataset of the company is inserted into the Google Colaboratory. Second, the dataset is pre-processed and displayed in a graph for better visualizing. Third, the dataset is normalized to the range of 0 to 1 to ease the LSTM training. Fourth, the dataset is split into training and testing sets with a ratio of 7 to 3. The table on the left-hand side is the same as the ARIMA algorithm due to the purpose of comparison. Fifth, the LSTM model is constructed. 6. The epochs and batch size parameters of the LSTM model are initialized. 7. The dataset is trained and predicted the monthly sales of the company using the constructed LSTM model. 8. The dataset is denormalized using the scaler into the original dataset scale. 9. The accuracy of the LSTM model is determined by evaluating the RMSE. The equation for calculating the percentage error shown is the same as the ARIMA algorithm. If the RMSE error is unsatisfied, return to the sixth step to change the epoch and batch size parameter. If the RMSE error is satisfied, proceed to the next step. 10. The unknown future 3 months monthly sales are predicted using the determined LSTM model. 11. The graph of predicted monthly sales of the company is displayed. This is the comparison table of the percentage error between ARIMA and LSTM algorithms. The percentage error for the ARIMA algorithm ranging from 71.60% to 85.84%. As for the LSTM algorithm, the percentage error is ranging from 8.84% to 12.64%. Thus, this result has proven that the deep learning algorithm LSTM is indeed better than the traditional algorithm ARIMA. This is the ARIMA prediction result for Assoc Tech Computer Inc. The orange line represents the actual monthly sales, whereas the blue line represents the predicted monthly sales. The gray color area in the graph shows 95% of the confidence interval. This circle shows the predicted 3 months monthly sales in May, June, and July 2021. This is the LSTM prediction result for Assoc Tech Computer Inc. The LSTM graph is the combinations of actual monthly sales with future 3 months monthly sales. This rectangular shows the predicted 3 months monthly sales. This is the ARIMA prediction result for Delta Electronic Inc. The circle shows the predicted 3 months monthly sales. This is the LSTM prediction result of Delta Electronic Inc. This rectangular shows the predicted 3 months monthly sales. This is the ARIMA prediction result for Taiwan Semiconductor Manufacturing Company. This circle shows the predicted 3 months monthly sale. This is the LSTM prediction results of Taiwan Semiconductor Manufacturing Company. This rectangular shows the predicted 3 months monthly sales. This is the ARIMA prediction result for Quanta Computer Inc. This circle shows the predicted 3 months monthly sales. This is the LSTM prediction result for Quanta Computer Inc. This rectangular shows the predicted 3 months monthly sales. In short, 3 objectives in this project are successfully achieved. Firstly, successfully collected and pre-processed the monthly total sales for all the 4 companies before undergoing training by both algorithms to ease the forecasting process. Second, successfully developed and proven that deep learning LSTM algorithm outperforms traditional algorithm ARIMA in predicting the monthly total sales for a company by having percentage error as low as 8.84% for LSTM and 71.60% for ARIMA. Lastly, successfully validate the future 3 months monthly total sales in May, June, and July of 2021 using both algorithms. The first research constraint is the percentage error for the ARIMA algorithm is very high, which is more than 70%. Second, the percentage error for the LSTM algorithm is unable further minimized to be lesser than 10%. There are 2 suggestions for improvement and future work. The accuracy of the ARIMA model can be increased by using seasonal ARIMA to detect the seasonality trend. Second, the accuracy of LSTM algorithm can be increased by training the dataset with more than one feature. Thank you very much.